Okay, so last section in chapter 5. There's a mistake. I'm supposed to say chapter 5. And that is radical equations. Section 5.3. So basically the purpose of 5.1 and 5.2 were definitely to develop those skills that you will use to rearrange equations from now until, well, forever, as long as you do math and science. But you often will come across in math and science, and in economics and statistics, equations that will involve radicals. Okay, so how do you solve these equations? Very important that we have to first talk about inequalities. Okay, inequalities is like one little fact that you have to, I suppose, recall about inequalities is that when you multiply or divide both sides of an equality by a negative number, you're actually going to reverse the direction of the inequality symbol. So take a look at this example. 3 minus 5n is greater than or equal to 0. As you get to this step right here, you have to divide both sides by negative 5 to isolate n. You have to remember to switch, okay, or reverse the direction of the inequality symbol when you divide or multiply both sides by a negative. Okay, this is going to come down to restrictions again. So I'm kind of building your toolbox when it comes to restrictions. So there are 3 types of examples. Equations with 1 radical term, there'll be equations with 2 radical terms, and there'll be a third example that will have equation of 2 radical terms, but it'll be slightly more complicated. So you can first of all take a look at the solutions of this question. Okay, I'll do a question exactly like this. So if you're struggling with the solution to this, I try to do it explicitly as possible. Maybe listening to my voice, and I haven't really looked at this question before. Like any of the other ones, I kind of try to work it through with you so you can kind of get the idea of how I work things throughout. Here we go. Practice 1. Identify any restrictions on y, okay, in this guy right here. If the radical is a real number, okay, then solve the equation. So I'm solving for y. First of all, let's state the restrictions. I'll do this in red. Restrictions. All I care about is that. Okay. 3 over 5 y has to be greater than or equal to 0. That is a 5. It looks like an 8, but that is actually a 5. I just cannot write. There we go. First of all, you multiply both sides by 5. This will give you, that implies 3y is greater than or equal to 0. And you can guess where this is going. Y has to be greater than or equal to 0. Okay, we didn't do this just do this for fun. Okay, when we solve this, you have to make sure your solution satisfies the restrictions. So there's a point to this. Now let's solve this. We have negative 8 plus 3 over 5, all square rooted, equals negative 2. My first step will basically be isolate. I'm going to try to isolate the radical. That will allow me to do a nice little square of both sides to remove it. Okay, if it's a cube root, cube both sides, and so on and so forth. So I'm gonna, get rid of this, move this negative 8 over to give me 3y equals 6, right? Negative 2 plus 8. Now here comes the step. I'll do in green. Square both sides. That will give me 3y over 5 equals 36. My 5's just turned into 8 somehow. Now I'm going to multiply both sides by 5. And 36 times 5 is 180. So we have 3y equals 180. And so y is going to equal to 180 divided by 3, which equals 60. Let's check this. First of all, it satisfies the restriction, right? It's clearly bigger than 0. To check this, which I'll do in red, you just plug it back in. So we're going to put 60 in. And the question is, does this equal -2? 3 times 60 divided by 5 square rooted is 6. So I have -8 plus 6. Does that equal -2? Oh yes, it does. Okay, that's how I like to format those. So we're right. And we know for sure we're right. So, pretty simple, right? Hopefully that made sense. The next one is you're going to have the variable split up between the radical and outside the radical. Okay, and this will possibly give you an extraneous root, which will be a root that you're going to reject. It will not satisfy the equation. Okay, it might not even satisfy the restrictions. It actually might satisfy the restrictions, but it might not satisfy the equation. Okay, that might be confusing. Maybe we want to replay that. But I'm going to do a similar example. Okay, so you can see my work here. First step will be to get the restrictions, then solve. You're going to have 2 solutions, and you're going to check both. One of them might not work. Okay, and then you're going to go with the one that did. That's basically it. So for here, same type of question. First step would be to get the restrictions. Okay, the question basically says solve. Okay, on an exam, I might not say state the restrictions. You're going to have to know to check. You need to check and see what this guy is. So in this case, 2m is greater than or equal to -3. So m is greater than -3 over 2. Okay, that is what I have to satisfy. Now I can go ahead and solve this. Okay, and I'm going to do so by isolating the radical. Okay, I'm going to try to isolate this. Sorry, when I write up top here, it seems to glitch out. I'm going to try to isolate that. Pretty easy. So I'm going to have -2m plus 3 equals 5. I'll divide both sides by -1 to give me 2m plus 3 equals -5. Now I can do my nice little, oh, what am I doing? Whoa, 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 whoa. Let's go back to this. What am I doing here? I somehow treated this m like it was a 1. And that is not correct. I'm sorry. This would be 6 minus m. So when you divide by this, you're going to have m minus 6. There we go. Now, we can square root both sides, or square both sides. Okay. This will give us 2m plus 3, and it will give us a nice binomial here. Okay, maybe I'll do off to the side. M minus 6, m minus 6. Multiplying binomials, this is m squared minus 6m minus 6m plus 36. So this is m squared minus 12m plus 36. Right? That is what we have. Now I'm going to collect like terms at this point. Here I'm going to collect like terms. Okay? So that will give us, and I'm going to move everything over to the right to maintain my, my positive m squared. Okay? So we'll be left with, I'll have 0 equals m squared, and we're going to have minus 14m plus 33. Okay, so here you can either factor, so you can either factor this or use the quadratic formula. I try to factor it first. If I can see, like I said before, if I guess and check if I can see it. You can use decomposition with this as well. Of course, I can already see the factor here, as you can as well. This is going to be 11 and 3. When you're dealing with 33, there's not too many factors, so it's pretty easy to check if you're going to find one immediately. In this situation, you're going to be dealing with, both of them are going to be negative. Right? So here m is equal to 11, or m is equal to 3. Okay, both satisfy our restrictions. So you're going to have to check. Okay, one of them may actually not satisfy the equation. So when you check, and I'll do it in actually I'll do it in red. You're going to have, let's check m equals 11 first. Okay, so let's do 11 times 2 times 11 plus 3. The question is, does this equal 6? Well, you're going to have 11, and then you're going to have minus 22 plus 3 is 25, so it's going to be square root 25. And does that equal 6? Oh yes, 11 minus 5 definitely equals 6. So that one works. Let's try 3. So 3 minus 2 times 3 plus 3. Does that equal 6? Let's see. 6 plus 3 is 9. So we're actually going to have 9, square root 9. Right? So it's going to be 3 minus 3, which equals 0, which does not equal 6. So this one fails. So we're going to reject that. So the root is m equals 11, right? And that's it. The other one's an extraneous root, and this root pretty much arose from this right here, from that step, right? Because the equation does not have a square in it. However, to rearrange it in a form that you can get a solution to it, you introduced this square, okay, which will produce a square term, which will produce another root, which is an extraneous root, okay? So, the last question, as you can see, if this question there's only one radical. The last type is when you have two radicals. Okay, 1, 2. Make a decision how you're going to solve this. Okay, check it by graphing. Ooh, I did not do that. Okay. Actually, you don't have to worry about that. Of course, you can graph this. But take a look at my solution. Okay, I probably checked it. I checked it just by plugging it in, just like I did before. That's solid. To look at the technique that I did here. Okay, and if it doesn't make sense to you, we'll do an exactly or a very similar question. Let's solve this. Now this one, the idea is to first of all, you're going to try to isolate the more complicated radical first. In this case, you have to make a decision. Which one looks more complicated? Probably this one right here. Okay, so let's try to do that one. They're both very similar. In the previous example, it was more clear-cut. You can see you have root 3x and root 5x plus 4. More clear-cut. This one clearly is more complicated. The idea, though, is quite simple. I'm going to isolate it. I'm going to square both sides. I'm going to do the same thing again. I'm going to isolate the remaining one. But let's try not to make a mistake. I'm going to predict this is going to be a complicated example in terms of how much work will be involved. So let's write neatly, and let's try not to make a mistake. And there we go. That's how we isolate it. Now we're simply going to square it. This will actually go from complicated. Sorry, this term right here will go from being the most complicated to the least complicated, because it's going to be 2j minus 1. This whole guy, I'll do the foiling, you can call it, or the distributing, or multiplication really, off to the side. This is where mistakes can occur, is when you try to do this in your head, okay, which I'm definitely suspect to. However, this is what it comes out to be. I'm going to check this, make sure I didn't do anything correct. 5 times 5 is 25. 5 times this next term is negative 5, root 3 plus j, but you're going to get the same term again right here. So therefore it becomes negative 10. And then this guy, the square root just disappears, but this negative out front becomes a positive. That's right. When you collect like terms, you're actually left with 28 minus 10, 3 plus j, plus j. So here we actually have 28 minus 10. See, actually, it's quite nice to do things off to the side sometimes. Okay. Now, name of the game. Let's now isolate this guy. Isolate him. You're going to do the exact same thing again. You're going to isolate it, and then you're going to square both sides. So in this case, you're going to have j on the side, because I'm going to move this j all over. I'm going to move 28 over to give me negative 29 equals negative 10. I have a feeling that I'm going to have to use the quadratic formula in this question, because I'm going to have to square everything here. You could divide by negative 10, but I prefer not to have a fraction at this point. So what you're left with here is j minus 29 times j minus 29, because it was squared, equals 100 times 3 plus j. Right? Now I have j squared over here minus, and what's 29? That's 58 j. And 29 times 29, what's that? 840 maybe? 29 times 29. 841. That was close. It can't be even though. 841 equals 300 plus 100j. I'm going to collect everything to the left. So I'm going to have j squared, and I'm going to have negative 58 minus 100. Is it better? Right? 841, this would come out to be 541 equals 0. Now if you can get those factors in your head, then you are impressive. I'm going to use the quadratic formula. I'm going to use the quadratic formula to find these factors. So you're going to have b squared, negative b, right, maybe I'll write it out, plus or minus the square root of b squared minus 4ac all over 2a. So that will imply you're going to have and negative b, so that's going to be 158, right, plus or minus 158 squared minus 4 times a, which is 1, c, which is 541, all over 2 times 1. That's what j equals. So in this case, j equals 158 plus or minus, let's get the discriminant down here. 158 squared is 24,964 minus 4 times 541 comes to be 22,800 all over 2. Wow. It's quite a bit. Square root of 22,800. Well, from here you can take out a 16 for sure. So from here you can get 4 times this. That's because this is 16 times 1,425. Okay. And this is all over 2. So this reduces down to j equals 79 plus or minus 2, and this 428. Now this is not finished yet, because this 1,428 definitely can simplify again. If I divide by 4, okay, and I actually apparently can't read my own writing. That's a 5, which will allow us actually to rewrite. We can pull out a 25. Anytime you see a 25 at the end, you should be able to pull out a 25, which will give you basically 25 times 57 here. Okay, so j equals 79 plus or minus 2 times, actually we'll have 10 out front because we're going to take out a 5, root 57. Okay, and there we have it. There we have it. Now, we're going to have to check. And to check for this problem, I would suggest using the decimal expansion. Okay, so what we have here is basically we have j is going to equal 79 plus 10 times square root 57, which will be 154.5, or j equals 79 minus 10 times square root 57, which equals 3.5. Okay, both satisfied this. And when you plug this in, so when you check it, and I'm running out of time here, but when you check it, you're going to realize that you're going to reject, okay, one of these guys, which will be this one right here. So your answer will actually be j equals 79 minus 10 root 57. So like I said, it's going to be a very long example, but you have to go very slowly. Once you get up to this step, just a matter of plugging into the quadratic formula. Typically I won't give you one that's this difficult to reduce down, okay? But you can see my thought process and how I worked it out. So work on the practice problems, then move on to the assignment, and then when you're ready, the exam.